Okay, today I'm going to talk about the mathematician Giovanni Ceva. So Giovanni Ceva, he was an Italian mathematician, and his contributions in various fields of mathematics and also scientists, but mostly mathematics, so including geology, trigonometry, and calculus. And he was contributed to several laws of science and also several theory. And I will talk about these tools in the following page with example. So several law of science. So we can see on this picture here. So in a random triangle, so A divided by sine A equals to B divided by sine B and equals C divided by sine C. But the several law of science can only be used when the triangle is not have a 90 degrees angle, and also we know one angles and its opposite sides. Then we can use the several law of science. Then now we're going to prove several law of science. We need to know the definition of science x. We need to know the definition of science x first. So which is sine x equals to opposite divided by hypotenuse. So here's the x angle, and this is opposite, and this is the hypotenuse side. Then we need to draw down a triangle ABC with a line H, which is 90 degrees. So we cut two angles A, B, okay, and so sine A, no, it's sine C equals to H divided by B, and so H equals to B times sine C. Then we know sine B, also same, equals to H divided by C. So H equals to C, C times sine B. So then we get B times sine C equals to C times sine B. Which also means B divided by sine B equals to C divided by sine C. So here we got the B and C part, and if we want to know the first part, actually it's all about relabeling the point. So here's an example. What is the angle A? So we know several law of sine. So here's what we do. Sine 47 divided by 15 equals to sine A divided by 9.5 equals to, so sine A equals to 9.5 times sine 47 divided by 15. And several theory is that if the line joining ABC of a triangle ABC to any point P in the same plate meets their opposite side DEF, then AF divided by FB equal times BD divided by DC times CE divided by EA equals 1. So then now we're going to prove the several theory So here we'll do, we will draw line QB and RC, which are parallel to line AD, and we will extend line CF to Q and extend line BE to R. Then in triangle QBF and triangle FAP, we got these are the two similar triangles because they have shear angles, and also they have angle Q equals to angles FPA, and angles QBF equals to FAP. So we got triangle FAD is similar to triangle FBQ. So AF divided by FB equals to AP divided by BQ. Then on the second triangle, we got the same situation. So triangle BDP is similar to triangle BCR. So BD divided by BC DC is equals to PD divided by CR. On the third picture, the triangle QBC is similar to triangle PDC. So BC divided by DC is equals to QB divided by QD. So BC, DC, PD. Okay. So on the final picture, these two triangles are similar. So triangle ECR is similar to triangle EAP. EAP. EC divided by AE equals to CR divided by AP. And then we'll write those four functions in one function. So AF divided by FB. Okay, AP divided by BQ. They are equal. And BD divided by DC PD divided by CR and BC divided by DC and QB divided by PD and EC divided by AE, CR divided by AP. And then we can cross some of them. AD, PD, and BQ and QB. So it means it goes to 1 on the right hand side. So we can also cross BC here, and then we got the similar expressions, which is AF divided by FB times BD divided by DC times CE divided by EA equals 1. And then here is an example for the Ceva theory. If RB divided by RA equals 2 times 3, and BP divided by PC equals to 4 and 5, and then what's the ratio of AQ and QC? So we know Ceva's theory, and then we can use it here. AR divided by RP times BP divided by DC times CQ divided by QA equals 1. So 1 equals to CQ, 3 divided by 2 times 4 divided by 5 times CQ divided by QA. So, it's AQ divided by QC. I wrote it wrong. Means it's equals to 6 divided by 5. Yeah, 6 divided by, yeah. So, thanks for watching.